In this problem, I'm asked how many moles of sulfur are contained in 12.6 grams of aluminum sulfide. Well, let's see. We're given 12.6 grams of aluminum sulfide, and our desired unit then would be moles of sulfur. So we need to go from grams of aluminum sulfide just to moles of sulfur. So let's go ahead and set up our roadmap. So we can go from grams to moles of aluminum sulfide. That's easily done. We just use the molar mass. And then I can go from moles, and let me write the aluminum sulfide in here, of aluminum sulfide to moles of sulfur. So let's go ahead and write out our two conversion factors. Remember, one for each arrow. So from going from grams to moles of aluminum sulfide, I need the molar mass of the aluminum sulfide. And the molar mass is 150.17 grams per mole. So we have that. So I can write out the conversion factors for that. So 1 mole of aluminum sulfide is 150.17 grams, or I can write it as 150.17 grams over 1 mole of aluminum sulfide. Great. So I have the conversion factor then for this first arrow. So now let's figure out how do we go from moles of aluminum sulfide to moles of sulfur. Well, if you look at the formula of aluminum sulfide, and I'll write that here, for 1 mole of aluminum sulfide, we have 2 moles of aluminum and 3 moles of sulfur. See, it's these subscripts that determine the number of moles in 1 mole of compound. So I can write out a conversion factor for that. So 1 mole of aluminum sulfide contains 3 moles of sulfur, or 3 moles of sulfur in 1 mole of aluminum sulfide. Again, it's these subscripts that give you the number of moles of each atom in 1 mole of the compound. So we're all set. I now have conversion factors for both arrows here, and now I just set up my problem. So let's see, we're given 12.6 grams of aluminum sulfide. So I want to cancel out grams and convert that to number of moles. So in order to do that, I need to use this conversion factor right here. So we have 1 mole of aluminum sulfide is 150.17 grams. So grams cancel. So now I'm in moles. So I've taken care of this part of the conversion. So now I want to go from moles of aluminum sulfide to moles of sulfur. So again, I want to cancel out moles of aluminum sulfide, so I'm going to use this conversion here. So we have 3 moles of sulfur and 1 mole of aluminum sulfide. And again, this cancels out, and we do the calculation, and I end up with 0.2517 moles of sulfur, but I have to check my significant figures here. I can only have 3. Okay, that's given here, so I'll go ahead. That's going to be 0.252 moles of sulfur. For the second problem, we're asked how many nitrogen atoms are contained in 22.6 grams of nitrogen, actually that's dinitrogen pentoxide. Well, let's see what we have here. So we're given 22.6 grams, and our desired units, we have nitrogen atoms. So how do we go from 22.6 grams of compound to nitrogen atoms. Again, one thing we always want to do is convert from grams to moles, because we can't relate grams to atoms directly. We have to convert from grams and then to moles of the compound. From there, we can determine the number of moles of nitrogen atoms in the compound, and then finally the number of nitrogen atoms. So let's go ahead and write out our roadmap. So we start with grams of the compound. We can convert that to moles. And from there, we can determine the moles of nitrogen. And then finally, from there, the number of atoms of nitrogen. So in this case, we're going to have 1, 2, 3 conversion factors. So 1, 2, 3 conversion factors. Well, our first one is just simply converting the grams of dinitrogen pentoxide to moles. So we can do that by using the molar mass. So let's see, our molar mass for 1 mole of dinitrogen pentoxide is 108.01 grams. Okay, so I can write that like this, or 108.01 grams per mole. So I have my first conversion factor. And then from there, I can determine the number of moles of nitrogen. So if we look at the formula here, for 1 mole of dinitrogen pentoxide, we have 2 moles of nitrogen. Remember, it's a subscript that will determine the number of moles of each atom in 1 mole of the compound. So for 1 mole of dinitrogen pentoxide, we have 2 moles of nitrogen atoms, or I can write it as 2 moles of nitrogen atoms for 1 mole of dinitrogen pentoxide. Okay, so I've taken care of conversion number 2. Now, once we get into moles of nitrogen, I can now relate the moles of nitrogen to the number of atoms. And I do that using Avogadro's number. So in this case here, 1 mole of nitrogen will contain 6.02 times 10 to the 23rd atoms of nitrogen. And of course I can write the other one, the other conversion factor, the other way. I'm running out of room here. Okay, for 1 mole of nitrogen. So now I have all 3 of my conversion factors that I need. So let's go ahead then and set up the problem. So again, I follow my roadmap. I start off with 22.6 grams of dinitrogen pentoxide. And I will use my first set of conversion factors to convert from grams to mole. So I'm going to have to use number 1 because I want to cancel out grams of dinitrogen pentoxide. So 1 mole of dinitrogen pentoxide, 108.01 grams. So grams cancel. Now, go back to my roadmap. Now that I'm in moles of dinitrogen pentoxide, I need to convert that to moles of nitrogen. So I know that 1 mole of dinitrogen pentoxide contains 2 moles of nitrogen. So 2 moles of nitrogen for 1 mole dinitrogen pentoxide. Okay, so that cancels out. And then finally, now that I'm in moles of nitrogen, okay, now I can convert that to the number of atoms. So what I want to do is I want to use the second conversion factor right here, 6.02 times 10 to the 23rd nitrogen atoms in 1 mole. And of course, mole cancels out. And then we do the calculation, and I end up with 2.52 times 10 to the 23rd nitrogen atoms. Okay, this next problem, how many moles of oxygen are contained in 3.2 moles of sulfur trioxide? So let's go ahead and work this. And what we have is, we have 3.2 moles of sulfur trioxide, so that's our given. And we're being asked how many moles of oxygen, so that's our desired. Okay, so this one's pretty simple because we just need to go from moles of sulfur trioxide to the number of moles of oxygen. And if we look at the formula, we know that 1 mole of sulfur trioxide contains 3 moles of oxygen. Or I can write it as 3 moles of oxygen for 1 mole of sulfur trioxide. So I'm all set. I have my conversion factor. So we're given 3.2 moles of sulfur trioxide. And of course I'm going to use conversion factor number 2 here. 3 moles of oxygen for 1 mole of sulfur trioxide. So moles of sulfur trioxide cancel out, and that gives me 9.6 moles of oxygen. That one was straightforward. Well, let's try this. How many molecules, how many sulfur trioxide molecules are in 3.2 moles? So how many molecules? And sulfur trioxide, and in the 3.2 moles. Well, how would we do that? We know that 1 mole of anything is equal to 6.02 times 10 to the 23rd. So that means 1 mole of sulfur trioxide molecules will be equal to 6.02 times 10 to the 23rd. So I can write those conversion factors. 1 mole of sulfur trioxide would be equal to 6.02 times 10 to the 23rd molecules. And then of course I could also write this as 6.02 times 10 to the 23rd molecules to 1 mole. So I just, so I'm going from moles of sulfur trioxide to molecules. And so I just need the 1 conversion factor. So we have 3.2 moles of sulfur trioxide. And we know that 1 mole of sulfur trioxide contains 6.02 times 10 to the 23rd molecules. So let's see what that is. I have 3.2 times 6.02 times 10 to the 23rd. And that gives me 1.93 times 10 to the 24 molecules of sulfur trioxide. I just thought I'd throw a twist in there. Remember, molecules, they're also particles. And remember, 1 mole of anything could be molecules, ions, atoms, eggs, is equal to 6.02 times 10 to the 23rd. Let's go on to this next problem. How many moles of hydroxide ions are contained in 3.55 grams of iron 2 hydroxide? How many hydroxide ions are contained in the 3.55 gram sample? Well, let's answer part A first. Okay, so we'll answer part A first. How many moles of hydroxide ions are contained in 3.55 grams of iron 2 hydroxide? Well, the first thing that we need to do is determine what we're given. So the given is the 3.55 grams of iron 2 hydroxide, and our desired is moles of hydroxide ion. Okay, so I can see right now we need to convert grams of iron 2 hydroxide to moles of iron 2 hydroxide. And then once I determine the number of moles of iron 2 hydroxide, then I can determine the number of moles of hydroxide ion. So I need two conversion factors. I have two arrows, two conversion factors. So the first one is just converting grams of iron 2 hydroxide to moles of iron 2 hydroxide. And I just need the molar mass for that. So 1 mole of iron 2 hydroxide is equivalent to 89.86 grams of iron 2 hydroxide, or I can write it like so. 89.86 grams is 1 mole. Okay, and so I have my first conversion factor, and then from there, once I have moles of iron 2 hydroxide, then I can determine the number of moles of hydroxide ion. Well, let's take a look at the formula. 1 mole of iron 2 hydroxide is going to contain 1 mole of iron 2 ions and 2 moles of hydroxide ions. Okay, the subscript here is going to tell us the number of hydroxide ions in 1 mole of the compound. So now I can write conversion factors. So 1 mole of iron 2 hydroxide is going to contain 2 moles of hydroxide ions, and I can also write it like this: 2 moles of hydroxide ions in 1 mole of iron 2 hydroxide. So I have the conversion factor for my second arrow. So now I'm ready to go. I'm just going to go ahead and set up the problem. Oops, I just lost my cursor here. All right, so let's go ahead and go with what we're given. So we were given let's undo that. Okay, so we were given 3.55 grams of iron 2 hydroxide. And I go back to my roadmap. I'm just converting grams to moles. So we need to use conversion number 1. So 1 mole of iron 2 hydroxide is 89.86 grams. So grams cancel out. And now I've taken care of this part. So now I'm converting moles of iron 2 hydroxide to moles of hydroxide ion. So I'm going to use conversion factor number 2 here. So we have 2 moles, because again, remember, I want to cancel out moles of iron 2 hydroxide and be left with moles of hydroxide ion. So 2 moles of hydroxide ion for every mole of iron 2 hydroxide. And that cancels out. And let's see, that turns out to be 0.079 moles of hydroxide. Okay, so there are 0.0790 moles of hydroxide ions in 3.55 grams of iron 2 hydroxide. Now, the second part of the question asks us, I'll just call that part B. How many hydroxide ions are contained in the 3.55 grams? So they're asking us here how many ions. They're not asking how many moles. That's a different thing. They're asking how many individual ions are contained in this 3.55 gram sample. So what I need to do is, I already determined the number of moles of hydroxide ion in the first part, but I'm gonna go ahead and draw out the roadmap anyway. So our given here is 3.55 grams. Our desired would be number of hydroxide ions. So what I'm going to do here then is do my roadmap. So I have 3.55 grams of iron 2 hydroxide. You need to convert that to moles of iron 2 hydroxide. Then we have to determine the number of moles of hydroxide ions, okay, in the sample of iron 2 hydroxide. And then finally, if we know the number of moles of hydroxide ion, we can determine the number of hydroxide ions. Okay, we've already done all of this in part 1. So all we need to do now is determine an equivalence and a conversion factor to go from moles of hydroxide ion to number of hydroxide ions. Well, let's see. We know that 1 mole of anything is going to give us 6.02 times 10 to the 23rd anythings. In this case, ions. Okay, so I can write that like so. And again, these are the hydroxide ions. So this one's pretty straightforward. All I need to do here is, again, I'm going to start with number of moles because we already did this in part 1. So I have 0.079 moles of hydroxide ions. And we know that 1 mole, I use this one here, 1 mole of hydroxide will contain 6.02 times 10 to the 23rd ions. So that gives us, when we calculate, 4.76 times 10 to the 22 hydroxide ions. That's a lot of ions. Okay. Well, I hope this helps, and thank you for watching, and have a great day.